My name is Tyson Boyd, and my topic for our project is finding the resultant vector using the component method. So a very important question is, what are components? And components are separate vectors that come together to make a resultant vector, which is what we're trying to find. What you see below is an example of two components put together to create a resultant. But in this example, it's using horizontal and vertical components, it is not always vertical and horizontal. And probably the easiest way to find a resultant, if the components happen to make a 90-degree angle, is to use the Pythagorean theorem. The Pythagorean theorem is a theorem of a squared plus b squared equals c squared, which can also be written as c squared minus b squared equals a squared, or c squared minus a squared equals b squared. So in the example below, one side is 3, one side is 4. So 3 squared is 9, 4 squared is 16, while we know that 5 squared is 25. And 9 plus 16 is 25, therefore 3 squared plus 4 squared equals 5 squared, which can be the same said as a squared plus b squared equals c squared. The component method means that the components start at the axis. Usually you're given these components as a direction and angle, or direction or angle, and magnitude or distance. So for example, this blue line here is 20 meters per second, which is a velocity, at 45 degrees east of north, and the red velocity is 10 meters per second at 20 degrees north of west. This next slide shows how we find where the resultant ends, and this can be found easily by making an invisible or imaginary lines duplicate of the first two that we found, the red and the blue ones, to make a parallelogram. The resultant is made from drawing a line starting at the axis to the opposite side of the parallelogram. By finding the horizontal and vertical components of the components using trig functions, we can find out that the second point of the resultant vector ends up. This will give us the horizontal and vertical components of the resultant. So in the example below, blue line is 20 meters per second at 45 degrees east of north. The red line is 10 meters per second at 20 degrees north of west. Using trig functions, we can find the horizontal displacement by adding the horizontal displacement of the blue line and the red line using the cosine. So 20 cosine 45 plus 10 cosine 160 is 4.75 meters per second, which is the horizontal component of the resultant. And with the vertical, we can use sine. So 20 sine of 45 plus 10 sine of 160 gives us 17.56 meters per second, which is the vertical component. And now that we have the vertical and horizontal components, we can use the Pythagorean theorem I talked about before to find the magnitude of the resultant. So by doing this, we could square both the numbers we got, 4.75 and 17.56, and then adding them together to get 330.92, and square rooting them to find m by itself, which is the magnitude, to find 18.19 meters per second. To find the angle of the resultant, you need to use the law of sines, which is sine of a over a equals to sine of b over b is the same as sine of c over c. In our example, I chose to use sine of p over p equals to sine of x over x, and we input sine of 90, which is the right angle at the top, over 18.919, which is the resultant magnitude that we found, equals sine of x, which is the thing we need to find, over 4.75, which is the top side, which is a. To find out what sine of x is, we have to multiply 4.75 by each side to get sine of x by itself, and then take the inverse sine of the other side to get x equals 15.14, which is the angle of the triangle that you created. The angle you get in your answer is not always the final answer, so you have to find where the angle ends up in bearings, unless you want to specifically tell the direction by saying east of north or west of south, etc. So in our example, we got 15.14 degrees, but putting that in bearing circle, it would actually only be 74.86 degrees because it is close to 90 degrees, but not in front of it. So the final number we would get is 18.19 meters per second at 74.86 degrees bearing as our final resultant. And that is how you find the resultant using component method.